So this set of notes is going to complete pages 27 and 28 in your notes. 27 will be review of our algebra properties, and page 28 we will be talking about how we are going to use conjugates. So let's go to page 27, our review of our algebra properties. So our first property that we are going to review is the commutative property. And we can use the commutative property in either addition or multiplication. So in addition, the commutative property says that z plus w equals w plus z. And in multiplication, the commutative property says that z times w equals w times z. So this is our any order property. So for example, in addition, 7 plus 2 is equal to 2 plus 7. And we know that that is true because 9 equals 9. Check. Or in multiplication, an example would be 7 times 2 equals 14. And we know that that is equal to 2 times 7, which equals 14. Check. All right, our next property is the commutative property. Oh, we just did that one. The associative property. And the associative property is any group. So, for example, in addition, we could say that we could first add z plus w and then add u. And that would be the same or equal to first doing z plus adding u plus w first, or w plus u first. And in multiplication, that would be like saying we could first do z times w and then multiply by u, or do w times u and then multiply times z. So an example of that would be we could add 3 plus 2 and get 5, and then add 4. Or we could do 2 plus 4 and get 6, and then add 3. Either way, 5 plus 4 equals 9, or 3 plus 6 equals 9. They are the same. In multiplication, we could use those same numbers. First, we could do 3 times 2 and get 6, and then multiply by 4 and get 24. Or we could start by multiplying 2 times 4 and get 8, and then multiply the 3 times the 8 and get 24. So either way, we ended up with an answer of 24. Our last property is our identity property. And for example, in addition, z plus 0 equals z. Or in multiplication, z times 1 equals z. So our identities mean that no matter what we do, which number we choose, if we add 0, we'll always get z. Or if we multiply by 1, our multiplicative identity is 1, because if we multiply by 1, it equals whatever number we started with. So for example, 3 plus 0 equals 3, or 3 times 1 equals 3. We get the same number we started with. So those are just a review of our basic algebra properties, which we are going to use in helping us solve problems using complex numbers, because those properties are going to extend to our complex numbers. Okay. Let's go on to page 28, and we're going to talk about using conjugates. So we need to understand what a conjugate of a complex number is. So for example, if z equals a plus bi, so some number a plus some number I, then our conjugate, which we write as our z with a bar over the top, so this bar means conjugate, would equal A minus BI. So the thing that changes is that our imaginary part of our number is the opposite of whatever it was in our original number. So an example would be if z equals 3 plus 2i, then z bar, or the conjugate, equals 3 minus 2i. And let's talk about some problems and how we could use conjugates to help us with these problems. So if we are talking about the equation w times 2 minus I equals 21 plus I, then one way we could solve this is multiply both sides of this equation by the conjugate. And that is always a useful tool when we are talking about complex numbers, is multiplying by the conjugate. And let's see what happens when we do that. So the conjugate of 2 minus I is 2 plus I. So we're going to multiply both sides by 2 plus I. That is the conjugate that we are multiplying by. I'm going to highlight that so we can see it on both sides. So we're going to distribute. 2 times 2 is 4. 2 times I is 2i. Negative I times 2 is negative 2i. And negative I times I is a negative I squared. And on the other side of our equation, 21 times 2 is 42. 21 times I is 21i. I times 2 is 2i. And I times I is I squared. And there are a couple of things that we can simplify here. So let's talk about what we can simplify. Notice that when we are multiplying by the conjugate, we have this positive 2i, negative 2i. So those two are going to drop out. And we know that I squared equals negative 1. So this is saying the opposite of negative 1, or negative 1 times negative 1. So we end up with 4 plus 1, or 5. And we're just going to keep bringing our w down the whole way, and we end up with, on the left-hand side, w times 5. And on the right-hand side, there are a couple of things we can combine over here as well. We end up with 21i and a positive 2i, which gives us 23i. And we know that I squared equals negative 1. So 42 and that negative 1, we can go ahead and combine those two together. And I'm going to highlight that I squared in pink also, so we keep that, remembering that that I squared equals negative 1. So when we combine that, we end up with 41 plus 23i. On the left-hand side, we have w times 5. So in order to do the inverse of multiplication, we're going to divide by that 5. So we have to divide the other side by 5. So we have solved this for w. W equals 41 plus 23i divided by 5. Neither 41 nor 23 divide by 5. So this is as simplified as we get. That's our final answer. We're going to try one more problem. So problem number 2 is if we were to have, for example, the problem 18 plus I divided by 3 minus I. Notice that when we multiplied by the conjugate up in our last problem, that all simplified down to a real number, 5. So we did not have to have that imaginary number in there any longer. So that's going to help us here. If we multiply by the conjugate of what we're dividing by, we will get rid of that imaginary number in our denominator, and it'll make it a lot easier to simplify. So the conjugate of 3 minus 4i is 3 plus 4i. And remember that if I multiply by a number divided by itself, this is really just like multiplying by 1. Because 3 plus 4i divided by 3 plus 4i is just equal to 1. So remember that we were just talking about our identities when I multiply by 1, z times 1 equals z. So I've not really changed this problem at all. I've only multiplied by the identity, so this is still the same number, even though it looks a little bit different. Let's go ahead and distribute. 18 times 3 is 54. 18 times 4i is 72i. I times 3 is 3i. And I times 4i is 4i squared. And then we have to distribute on the bottom as well. So 3 times 3 is 9. 3 times 4i is positive 4i. Negative 4i times 3 is negative 12i. And negative 4i times positive 4i is negative 16i squared. There's some things we can simplify here again. So we've got this 72i and the positive 3i that we can combine together. And we know that I squared equals negative 1. And on the bottom here, in their denominator, we've got, again, this negative 12i and positive 12i that are going to equal 0. So that is gone. And over here, we've got this I squared, which we know is equal to negative 1. So all of those are things we can simplify. And this becomes 4 times negative 1, or negative 4. And 50 plus negative 4 is just 50. And 72i plus 3i is 75i. Since the 12i and the negative 12i are gone, I now have negative 16 times negative 1, or a positive 16. And 16 plus 9 is 25. This time, we do have numbers that are going to be able to divide. 50 divided by 25 is 2, and 75 divided by 25 is 3. So we can go ahead and simplify this one step farther, and our final answer will be 2 plus 3i. And that's it.